So following on from the previous video, I've got here the database from Spotify. So in the previous video, what we did was we used Python to build a pipeline from the Spotify API to generate this database here. And in this video, it's just going to be a follow-on from here, where we'll just be going through visualizations created of this database and see if maybe there's any interesting information, and we'll just follow on from here to Tableau. But first things first, we're going to just undergo a matplotlib visualization or an analysis procedure and see what or how we're going to break this analysis down. So I've got my matplotlib file open here. The main thing to know is that this is a PostgreSQL database. So we're going to connect to the database using CyclePG, and that's what I did here. So we're just gonna use the actual class to create a connection item, and we're going to use that connection item within the pandas class to actually generate that same database as a data frame. So here's our data frame here. First thing we'll do is check our artists column here. If you remember how the actual pipeline was built, the input data that we use to generate these tracks was the actual artist name, and the number of artists, as we see here, that we used was 97. So the actual database has got 97 artists. So if we wish to create a bigger database, we'll need to expand the number of artists within the or which we use to as an input in the pipeline. But with the 97 artists, we've got about 14,000 line items here, which is an indicative of 14,000 tracks. So there are 14,000 tracks in the actual database, and each track has got about 12 features. So it's going to have its track ID, the title, the duration, the artist who released the track, the artist ID, the genre, the artist popularity, the album name, the date that it was released, the album ID, the total tracks, available markets, album types, and the track popularity. So we're gonna use the dat.info method just to make sure that each of the numeric columns which we expect to be numeric are indeed numeric. We've got here the float, integers and more integers, and we expect the track popularity to be an integer. So we can proceed with this data as it is. The first thing we'll do is we'll focus on those numeric columns to see the distribution of them in the data set. If we plot track duration in seconds, we see this this bell curve where most tracks seem to be we see it's plotted in seconds. So most tracks seem to have about 25,000 below 25,000 seconds as their duration is below 25,000 seconds. We'll need to go deeper in here and just make sure that this is more intuitive. Next is the artist popularity, where we see that most popularities, they range from 70 to 100, and the popularities of the artists and the tracks seems to be a variable which ranges from 0 to 100, and the more popular an artist is or a track is, then we would expect the actual variable to have a number closer to 100. So artists range from 70 to 100, and most of them lie on the 85 range mark. Then we've got the total tracks in the albums, which most are about less than 20, but some do range to about 100. So some albums have got about 100 tracks within them. Then the available markets, it ranges from 0 to 175, but we see that most are either in the like a 0 or 1 or 2. So these beginning numbers or the higher range numbers. So these are the number of countries that the album is available in, and most albums seem to be highly available on Spotify to most countries. Then we've got the track popularity. That the median seems to be at number closer to 40 or to 50. So most tracks on the database have got a track popularity of 50. So we want to know, is there any insight that we can get? What are the what correlations can we build from the track popularities to other variables? What actually causes a track to have a higher popularity, and can we get that insight from the other features within the database? That's what we'll be doing as we go on in this analysis. So let's focus on the actual track duration. If we use an SNS.hisplot, where x is the track duration in seconds, it recreates this track duration plot. But again, it's in seconds, so we'll need to convert this into minutes just to make it more intuitive or more understandable to us. So what we're going to do is we're going to create a function where that function is going to return the rounded value of the duration divided by the 60,000, so that this is going to convert it to a minute. So it's going to convert each of these track durations to a minute, and we're going to use that function to create a new column, and that column I'll give it a name, track duration in minute, and I'll apply this function using a lambda expression, and it's going to loop through each of these items in the database and output the track duration in minutes. If we display the head of the data frame, we see that we've got a new column here, which is the track duration in minutes, and this is a better representation of the durations. And if we just plot this using SNS.hisplot, we see now we've got a much more intuitive plot, where we see that most tracks have got about 3 to 2 to 4 minutes duration, and some do go up to 30 minutes, given the fact that the graph does go up to 30 minutes. So it does seem that there are some tracks which they reach 30 minutes long. Let's just see if we can get some sort of correlation between the track duration and the actual popularity of the track. So what you're going to do is we're going to plot this track duration and the track popularity on an LM plot. So it's going to be a scatter plot, and we're going to have the track duration on the x-axis and the track popularity on the y-axis. And it seems that this is just going to be the what you call the his plots plotted, but on the same axis, where we've got track duration on one axis and track popularity on the other. And we see that indeed there isn't any kind of correlation that we can get in terms of the track duration. So in here we want to answer, does the track duration affect the track popularity? And maybe that is dependent on other factors, but for all the tracks it seems that we cannot get any conclusive information. So let's move on to analyzing the genre. So the actual data frame has got these genres here, and those are a categorical feature. So we'll use a count plot method. So this plot is going to count each of these instances here. And if we plot this and put every value in ascending order, we see that the actual the genre with the highest number of what you call instances is the dance pop, and next is the contemporary country, then hip hop, then so on. So it seems pop and contemporary country are they are mostly represented in the database. But if we move on, what I did here was I said, okay, let's see if maybe we can say any track which has got hip hop, then we would classify that under one category, hip hop. We see it as dance pop and then pop. So to me, that's ambiguous. So let's create a function where it is going to go through each of these items, and wherever it sees dance pop, it is just going to attribute that as pop. And to create that, I'll just create a list, and that list I'll use it in a function where it is going to loop through each item in the data frame, and wherever it sees a genre with a hip hop within it, irrespective of whatever preceding description there is, it'll attribute that genre to hip hop, and so on with the other genres. For example, I've got here soul, rap, pop, R&B, rock, country, and other. So I want to take down the number of categories here, and when I run this function and I loop through the actual database or the data frame using a lambda expression, and I plot the very same plot here, this is what I get. Again, the pop is highest, but now hip hop takes over second, then we've got other, then country, then we've got rap, rock, R&B, and then soul. So I think this is a much better representation of here. We can proceed with this data as it is. It might be argued that we might be taking out, or we might be decreasing the amount of data that the actual data frame has, but we can always reference back to the actual original genres, because this genre is just a new column in the data frame. So pop is highest, followed by hip hop, and the rest follow next. So let's use those genres to see if there's any to see the distribution of the track popularities based on the genres. So I'll create a box plot where the X is going to be the genre. So I've created an SNS box plot. The S is going to be the genre variable which I've just created now, and then the Y is going to be the track popularity. And if we use that, we see that we get back this box plot where there are these track popularity ranges. So we want to see if there are any genres which have got, which for example might have tracks which have got a higher popularity, and we see that they are fairly similar. For example, the soul, for example, has got a higher overall, or the median of the track popularities in soul tracks are much higher. But maybe if we come back here, we see that the number of representation of soul tracks in the database is quite low. So maybe there's not much you can deduce from this. But all in all, there isn't a fairly, or there isn't a genre which has got what we call a higher track popularity average. So let's use the same genre column to see track popularities, but now I've plotted for track popularities above 80. So if we remember here, most track popularities range from 0 to 100, but I want to see now from 80 above, what is the distribution there? Where do most genres lie? And we see that pop has got this outlier with one track which has got a popularity of 100, and so we want to see the tracks which are, or the genres which have got the highest number of representation in this higher track popularity range. And we see that most of these are not what you can say, there's not much difference in terms of the way they distribute in these higher ranges. We do see that R&B has got the highest median of all the genres, but it seems here that the outliers are the only tracks which are higher than the rest. For example, here the pop has got a track popularity of 100, and next is hip hop with a track popularity of just under 95 there. So let's see if we can plot other visualizations. Can we link the track popularities to other variables? We're going to check the artist popularity, and in this case we're going to recreate the distribution, the his plot here, but now we're going to use matplotlib just to get these bars more closer to each other and get a bigger plot so we can see what's happening. So the popularities range from 70 to 100, and most lie within the 80 to 85 region here. So zoom in there. So if we use the genres now versus the artist popularity, so here what we want to do, we want to check the artist popularities and see which genre has got the highest number of popular artists. And it seems here that R&B could be the genre which takes this round, followed by pop, and then the last is going to be country. It seems that country artists have got the lowest popularities, but so it's going to be R&B, pop, then next is going to be a tie between hip hop, rap, and rock. But we see a soul does not have much of a box plot, and it could be that most tracks, or most soul tracks, or there aren't as many tracks of soul in the database as for other genres. So if we move on, so next let's plot the scatter plot here, where we're checking the artist popularities and the track popularity. So here what we want to check is, what is the track popularity based on the popularity of the artists. And this scatter plot, of course, is trying to get, we want to see if there's any correlation between artist popularity and the track popularity. And from the visualization, there isn't any kind of overall correlation between these two variables. But what we do see is that if we go on the higher track popularities, there is this slight what you call linear relationship, but only for popularities ranging from above 75 to 100. There is this steady increase, that the higher the artist popularity, the most likely they are to release a track which has got a higher track popularity. So if we move further down, let's try to see if there's any way in which we can manipulate this data in a way where we can focus on these higher track popularities and see any kind of correlation. So what I'll do is that I will group, I will use the data frame, and I'll use the group by method, where I'll group by the artist popularities, and I want the new data frame here to output the track popularities, the mean of the track popularities back, and I want to plot those two variables together. So in this case, let me show the head of this data frame here. So let me say dot head, and we see that we've got the artist popularity and the track popularity somewhere here. So this is going to be the mean of the track popularity. So let's plot this versus the track popularities and see if there's any correlation. And when we use an LM plot where the X is the artist popularities and the Y is the mean of the track, we see a steady increase in the mean of the track popularity. So the higher the artist popularities, the higher the average popularities of all their tracks, it seems. So this is what the visualization is telling us. So if we use the very same method here, but instead of using the mean method, we use the max. So we're going to get not the mean of the track popularities, but the max. So we'll check each artist with a popularity of 70 and output the maximum. For all those tracks, we want to know what's the maximum track popularity, and we want to plot that. And again, we see, well, correlation between the two, which you would expect, of course. I think most artists are made popular by one popular track. So the higher the artist's popularity, the higher the probability that they have at least one track within their album with an extraordinarily high popularity. So let's move on from artist popularity and let's check the artist track release dates. And we want to see, does the month that the track was released, or the album which does the month in which the album was released affect the popularity of the actual track? So what we're going to plot first is the count plot. We want to check how many instances, which month is the highest as far as number of tracks released. And it seems here that first of all, the months are represented in numbers. So they're going to start from 1 to 12, and then 1 is going to signify January here. So it seems most tracks are released either in January or in November. And then there's this peak in May. So we're going to see if there's any interesting trend that we can drill into here. What I'll do is I want to create this heat map here, and this heat map is going to sort of like reproduce the same graph here, but I want to split this in terms of genres. So I want to know what is this distribution in terms of genres. So I've decided to use a heat map. And so what I'll do is I'm going to create a new data frame where I'll group by the genres and release month, and I'll use the unstack method here, where I will use the count method to count each instance for each instance of tracks based on the genres and the release month. And I'll use a function to make sure that I remove all null values. I don't want to see instances in this heat map where there isn't a number. So I want to either have a 0 or a number. So if I don't have this function, what will happen is I'll get nulls here, and I'll just get blanks. So I'll just get whites. So I want to have, if it's a null value, then it's 0. What it means is there wasn't any track released in that month for that particular genre. So I'll just replace that by 0, and I'll use that function together with a lambda expression to create that and to correct that issue. So if we plot this graph, we see now the heat map where most again, most tracks are released in January, and it seems it's highly affected by this pop, and also by this hip hop. It seems to follow the same general distribution, but as far as hip hop, we do see this peak in May, which again was shown here, but it seemed that this was influenced by the high number of hip hop releases. So if we move on to the next visualization, what we have here is the visualization where we are trying to plot the month of release and the popularities, but for individual genres. Now, the aggregation function which is used here is the max aggregation function. So in this case, I'm trying to find the maximum popularities for each month for a particular genre, and then see if maybe there's any correlation based on which month that track was released, that particular track which has got the highest popularities. And it does seem that for country, the track with the highest popularity was released in May. Next, the hip hop, the track with the highest popularity was released in April. And so what I want to do now is I want to recreate the same plot, but now I want to change this max now to the mean or the average. I want to see the distribution of the average track popularities and see how the release month affects that. So I'll just copy this. And I'll paste it here. So I'm going to change this to mean. In this case, I'll run this. And then I think I'll need to run the actual function. So this is what we get. So these are the average track popularities, and it seems that for country and hip hop, the tracks or the months which have got the highest track popularities are December and right in the beginning of the year, around March, April for country. Then for others, it's in April, and then for pop all year round until, let's say, August. It seems the tracks have got above average popularities, and then for R&B, there is a case where tracks released in February and later in the year seem to be the tracks which have got a higher than average popularity. But if we just check the actual distributions of the popularities in which are plotted, for example, in pop, we see that they don't go higher than 45. So in the whole grand scheme of things, maybe this information is not too valuable to us, but it's well worth the try nonetheless. So what I'll do now is I will download the dat data frame, and that data frame I'll store it as an Excel file. So what I want to do now is I want to take this visualization next to Tableau, and I want to see if I can recreate the same visualizations and more, and see if we can better summarize this database that we have here. So this is my Tableau visualization, or the whole project which I've summarized here. So I'll just go through each plot, and some are going to be duplications of the plots that we have before, but some are going to be different. This is just the track duration. This is just going to be the distribution of each track. So it's going to be a bar graph or a his plot, a horizontal his plot showing the distribution of the durations. And then next we have the distribution of the artist popularity and distribution of the track popularity. So this is just showing the actual raw data as it is from the Excel file. We've got the same the same track duration versus track popularity scatter plot that we had in the Jupyter notebook, and I've went ahead and recreated that. And I believe that if we highlight a few genres, hopefully the user can try to drill down to their actual preferred genre, if they wish to investigate further, if indeed there are any correlations between these two variables. Then we have the genres. This is just a visualization showing the different sizes and correlations of each genres in the database. Then I went ahead and plotted the same visualizations that we had in the Jupyter notebook, where we are comparing artist popularity and track popularity, and we plot also the actual trend lines, and there does seem to be, a correlation, but can we confirm indeed? Can we make a conclusive observation that this is indeed the case? That is up to interpretation of the whole data set. But from the data set as it is now, it seems that indeed there does seem to be generally a correlation between if an artist has got a higher popularity, their maximum track popularities and median track popularities seem to increase. Then I went ahead and plotted a release date plot here, where it's just showing the number of tracks released for each year. So we didn't have this plot in the Jupyter notebook, and in this case, it's a plot which gives us another look or another view in the dataset. It shows us that indeed the dataset that we have has got tracks which are predominantly recent. There aren't a lot of tracks from before 2010, and maybe it shows that most of our listeners on Spotify are interested in contemporary or new and upcoming artists. They're not really interested in artists from 2004, 5, and 6. So this is quite an interesting chart. So it's an area chart, and it's been split on the actual genre. So that's going to be in the colors. So each color here is indicative of the genres. Then the next is going to be the summary of all the artist popularities, the top 10 artist popularities. And I've gone ahead and used a parameter here, and that parameter will the user can make use of it to see if maybe they want to see more artists. They want to see a longer list of artists. I'll just leave it at 10 for now. And then the last plot will just be the release date, and it's going to be a plot where on the x-axis the release date, on the y is going to be the count, which is a bit similar to this plot, but here above we are now checking the actual duration of the track, so the average durations, and we want to see the general track durations and how they've evolved over the past 20 years. And here we are researching average track duration. So I've went ahead and plotted the count plot of the actual number of released tracks, just to put this scatter plot into perspective. And finally, we've got the completed dashboard of our database right here, with all our plots, and went ahead and made sure that all the plots are indeed filter friendly, and the user can make use of these filters to try and zoom into the kind of genre that they're trying to research. And also keep in mind that these genres are all made up. They were not coming straight from Spotify. This is they are not as they came from the actual API. They are what you call trimmed down versions of the originals. So yeah, so this is the end point of the whole exercise, and hoping that the actual end point is useful. What we can make use of, or what we can deduce from this is, if we can change the number of artists in our Jupyter notebook here, or not just the number but the actual personnel, and make use of our API pipeline, we can easily update this whole dashboard, and hopefully get even more interesting, insightful information, which is ever changing and can easily be updated